Okay, let's talk about another example, number 6. Okay, so the process is same, right? We're gonna apply a Laplace transform, like for your differential equation. Then we're gonna do the lifting on your left-hand side for y double prime, okay? And then we're gonna find Laplace transform of your Dirac delta function on your right-hand side and with your table. And then we will solve for y of s, then inverse transform. That's everything, okay? So let me show you how we can do it, okay? Here we go. Apply the Laplace transform, then it will be with a linearity property. It can be written by Laplace transform of y double prime plus 4 Laplace transform of y equal to Laplace transform of delta function of t minus pi and another Laplace transform now, Laplace transform of delta function with t minus 2 pi. That's it, right? So like first part, this is lifting, right? Then what happened? S squared ys minus s y0 minus y prime 0. That's it, okay? The second part, 4 Laplace transform y is 4 y s, and with the table, let me give you a table, number table, okay? It is number 17, okay? Then it is e to the minus pi s minus e to the minus 2 pi s. That's it. We are ready, okay? So let me use all the given initial conditions. y0 is 0 and y prime 0 equal to 0 as well. Then we can solve for y as equal to, so let me factor out. Then we're gonna have this guy and right hand side. Almost there, okay? Then as you know, we divide by s squared plus 4. Okay, again, we are keep doing same practice, right? So you should know about what you're doing, okay? It might better to write like this way. I will tell you why, okay? Well, like instead of 4, it might better to write 2 square. You know what I mean, right? Because we're gonna use the table number 5. That's why, okay? There we go. We're almost there. Now, like we're gonna apply number 13 first, and to the so, uh, I'm saying number 14. Yeah, number 13. Okay, then we should do this one as h of s, right? If I define h of s, like if this part as h of s, then we can easily say your yt, let me do the imply, is the first part is constant with pi, right? Which means u pi tn h of t minus pi, because your c is pi, right? And second part minus u 2 pi tn h of t minus 2 pi. You know what I'm saying, right? I just use like this one and this one as one combination, first one, and e to the minus 2 pi s and this h of s as second combination, okay? And then like we have defined h of t. Let me define here where my h of t is inverse Laplace transform of h of s, which is inverse Laplace transform of 1 over s squared. Perfect, right? But okay, for here, you have to think about what is that? It is number 5, right? Here we go, number 5. 12, your understanding, let me write, okay? Laplace transform of sine at is equal to a over s squared, a squared, okay? Well, look at that. Can you find it? Numerator and this part must be same to each other, right? Oh, look at that. This is 2. Oh, it's not 2, right? Then you have to make it 2. Then you have to divide by 2 as well, okay, at the same time. So that is equal to 1/2 out and inverse Laplace transform of 2 over s squared plus 2 squared. Perfect, beautiful, right? Then it is exactly sine 2t, right? Is equal to 1/2 sine 2t. Is that clear so far? Now, well, again, this is not the answer. Okay, we found one part of your answer, right? So we can plug in t minus pi and t minus 2 phi to complete your problem. Okay, here we go. So finally, your answer, your solution curve, y of t is equal to u pi t times h of t minus pi, and we can put t minus pi here. It is 1/2 sine 2 times t minus pi. Let me make it a little bit lower because we have space. Okay, and then the second part plus u 2 pi t times 1/2 times sine 2 t minus 2 pi. Perfect. This is done, but like some of you asked me to simplify a little bit. Yes, I can do it. This guy, what is that? 2t minus 2 pi. 2 pi minus 2 pi is like a clockwise one circle. So this whole thing is just like simply sine 2t that we find. And this guy, it is like 2t minus 4 pi, two circle, but it is still sine 2t, right? So we can rewrite this one as 1/2 u pi t sine 2t plus 1/2 u 2 pi t sine 2t as well. Are you with this part? Oh, like, we can simplify more, but, well, like that's it. This is fine. Okay. Or like you can simplify more. But when I check your online homework, question asks you to write this kind of like your unit step function form as a piecewise defined function, okay? But it is easy, okay? Look at that. We have like 2 point pi and 2 pi. Then we're going to consider the from 0 to pi and pi to 2 pi and bigger than 2 pi, okay? So we're going to make like a the piecewise defined function with 3 separate interval, okay? Like this first one. If your t is between 0 and pi, what happened? U pi is equal to 0 because your t value is less than pi, right? And then u 2 pi is also 0. So whole thing is 0. But second part, between pi and 2 pi. Well, in this interval, since your t is bigger than pi, this is survival, okay? U pi t is 1, but u 2 pi equals 0. So you're going to have like only this part, which is 1/2 sine 2t. The very last one is when t is bigger than 2 pi, then this is equal to 1, and this is also equal to 1. Oh, give me 1 second. I found it. I'm lucky. Here we go. It was minus, not plus, okay? My bad. This minus, and this is minus. I'm sorry about that, okay? But like, fortunately, like there's no difference with that, okay? But when t is bigger than 2 pi, what happened? This is 1, and this is also 1. Then 1/2 sine 2t minus 1/2 sine 2t, which is equal to 0, okay? So this is the way to write your function in terms of unit step function as piecewise defined function, okay? Thank you.